Hello everyone. So in our previous video, we discussed step-by-step demonstration of how we can merge two sorted arrays. In this video, we'll actually code the algorithm and we'll test its working. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss an update. So here I have created one class as merge sorted arrays, which is having a method as print array, which takes in an array and print its elements on the console. So we have discussed this print array method in our previous videos. So I will simply use this print array method to demonstrate how we can merge two sorted arrays in Java. So here you can see I will be creating one method as public whose return type would be an integer array, because we want to merge two arrays which are sorted and we want to return back the merge sorted array having elements of array 1 and array 2. So the method name I will be giving as merge. This method will take four things. One would be the array 1, other would be array 2, the length of array 1 and length of array 2, which is being denoted by n and m. So here you can see that array 1 and array 2 are already sorted arrays and we want to merge them together. So at the first step what we do is, as we want to merge them, we'll simply merge them in the result array. So we'll create a result array. Now the size of this array would be n plus m, because we want to accommodate the elements of array 1 and elements of array 2 into the result array. So the idea behind this algorithm is we create three pointers I, which will start from 0. So this pointer will traverse array 1 from start to finish. We'll create one more pointer which will start from 0 and it will traverse array 2, and we'll create one more pointer k which will start from 0 and which will traverse result array. So here why we have created this three pointer is because pointer I will traverse array 1 elements one by one and j will traverse elements of array 2 one by one, and we'll simply compare those two values stored at I and jth index, and based on our comparison whichever value will be small we'll simply store it into the result array at kth index, and after we store this value, whichever value of that particular array we get as a small, we'll simply increment pointer of that array, and after filling the result array at kth index we'll also increment k by 1. So here, in order to perform that, we provide a while loop, and inside that while loop we provide two conditions. One is I should be less than n and j should be less than m. So these are nothing but boundary conditions where we are simply checking that whether I is in the boundaries of array 1 and j is in boundaries of array 2. And we have provided this AND condition because in this while loop we are comparing the value stored at ith index with the value stored at jth index for their respective arrays. And in case any of this array gets exhausted, which means that either I will cross over array 1 or j will cross over array 2, we simply break from this while loop. So inside this while loop we are providing a condition as if value at ith index of array 1 is less than value at jth index for array 2. So here it signifies if array 1 element at ith index is less than array 2 element at jth index. So if this is the condition, then after this comparison this value is the smallest value, and as we want to merge these two sorted arrays into a result array, and that also should be in sorted form. So therefore we simply update the smallest value at the kth index, which means storing array 1 element into result. And after we store array 1 element, we have occupied the ith position into the result array. So we'll increment I so that we can go to its next index. And similarly, if this condition is false, then in the else part, we do the opposite of it. We store the value at jth index for array 2 into result, because here we know that if this condition is false, then value stored at jth index for array 2 will be smaller than this value. So we are storing that value into the result array, and as we have used the value stored at jth index, we will simply increment j by 1. So after storing the minimum value among these two values into the result array, we have filled the kth position in the result array. So we'll also increment k by 1 so that k traverses to an unfilled position, so that when this while loop will be executed again, we are left with a unfilled position. So after this while loop gets terminated, there can be two possibilities. Either array 1 got exhausted or array 2 got exhausted. If array 2 got exhausted, which means that all the elements of array 2 are now part of our result array, and whatever leftover elements are there in array 1, we simply copy it into the result array. So for that we'll use the while loop. We provide the same condition as I should be less than n, because we are simply copying the leftover elements of array 1 now. So we copy this and will increment k also by 1 after filling the position. So here this while loop signifies that array 2 got exhausted. And similarly, we don't know that which array got exhausted in this above while loop. So we need to provide the same while loop for the array 2 as well. We provide the condition as j should be less than m. This will signify that array 1 got exhausted first. We'll increment j by 1 and we will keep rest as it is. So friends, here you see that why we have provided these two while loops is because we don't know whether array 1 got exhausted first or array 2 got exhausted first. So if array 2 got exhausted first, we are simply copying the leftover elements of array 1 into result. And if array 1 got exhausted first, we are copying the leftover elements of array 2 into the result using this while loop. And why we are simply copying these elements from the respective arrays, because those elements are already sorted and we don't have to compare it with any other elements. Whatever the comparison we need to do, we have done it in this while loop. So at the end, we'll simply return the result array. So friend, this is the code for merging two sorted arrays. Now let's test its working in the main method. So here I will be creating two arrays. Array 1. Let's say I provide the value as 0, 1, 8, 10. These four values. And here you can see these are sorted in ascending order. And similarly, I create array 2. Let's say I provide value as 2, 4, 11, 15 and let's say 20. So these values are also sorted in ascending order. Now let's print both these array on the console. If I run the code now, so here you can see it is simply printing both the arrays on the console. Now we will call our merge method. We pass in array 1, array 2, length of array 1 which is denoted by n, and length of array 2 which is denoted by m. So this method will return us the result array. So we'll store it into the result variable, and finally we'll print the result array. If I run the code now, so friends, here you can see that it returned 0, 1, 2, 4, 8, 10, 11, 15, 20. It merged these two sorted arrays and returned us the result array, which is also in sorted form. So friends, this was all about the code and working of the algorithm. Now why this algorithm is important? Because the similar approach is usually used when we actually perform the merge sort, which we will be looking into our upcoming lectures. So there we'll simply use this idea and we'll perform the sorting of array using merge sort. So friends, if you find this information useful, then please like, comment and share this video. And in case if you are new to my channel, then please subscribe to my channel so that you don't miss any new update. Thanks, have a nice day.